times as much water as all of Earth's combined. Arriving at the Jovian system in December 1995 with the aim of exploring Jupiter and its large moons, Galileo passed by Europa multiple times, coming as close as 201 kilometers above its frigid surface. It captured its frozen terrain in incredible detail, allowing us to see close-ups of its cracks, ridges, and jumbled up landscape, but also find intriguing evidence of what might be happening below its crust. Galileo confirmed that Europa was geologically active. Its close-up images revealed the enormous cracks in the moon's surface had separated, and dark, icy material had flowed into the open gaps. As with the spacecraft that came before it, Galileo also found only a handful of impact craters, which are expected to build up over time as the surface is constantly bombarded by meteorites over billions of years, much like our own moon, for example. But Europa is smooth, suggesting that its surface is relatively young and that something had erased any large craters, such as icy volcanic flows. One of the most important measurements made by the Galileo mission, however, showed how Jupiter's magnetic field was disrupted in the space around Europa. This measurement strongly implied that a special type of magnetic field is being created within the icy moon by a deep layer of some electrically conductive fluid. Based on Europa's icy composition, scientists think the most likely material to create this magnetic signature is a global ocean of salty water. There are even images from the Hubble Space Telescope that appear to show huge plumes of water vapor erupting from Europa's south pole, although unfortunately they are not high resolution enough to be definitive. But if Europa's surface is frozen solid, then how could a massive ocean of salty water form? And if there is liquid water down there, could life have really started in such a bizarre environment? While the icy shell of Europa is clearly frozen as hard as rock, the interior is warmer because it is heated by what's called tidal flexing. The side of Europa that is closest to Jupiter experiences a stronger pull than the other side, stretching the entire moon back and forth, probably causing the long cracks that run across its icy surface, as well as heating the interior through friction. Similar to how repeatedly bending a paperclip generates heat, for example. It is this constant flexing that melts the internal ice and creates Europa's enormous ocean. But is it really possible for life to start on a frigid moon hundreds of millions of kilometers away from the sun? Well, life as we know it seems to have four main requirements: liquid water, certain chemical elements, an energy source, and of course, time. We have already discovered that Europa may have an enormous ocean of liquid water that is protected below its crust. And certain studies of the ocean have suggested that it may have formed just a few 100,000 years after the moon formed, which is estimated to be around 4.5 billion years old, as can be seen in this incredible infrared image. Europa is shown as blue, while the carbon is white, and it is thought that it likely originated from the ocean below. Then we need an energy source. All life as we know it requires it to survive. Here on Earth, life